So the last section in chapter 10 is going to have us working with polynomial inequalities, polynomial and rational inequalities. So let's take a look at some of the problems, starting with the polynomial inequalities. An example of one of those is x squared plus 2x minus 8 is less than 0. Now on the surface of this, it seems a lot like what you're used to, which is, oh, well, this is just like a polynomial equation. And it's going to start that way, but it's not going to end that way. So before we do problem number 16, let's do the one on your handout because it's kind of a nice guide as to what you're going to do on these types of problems. So here's an example of a polynomial inequality. The first thing you need to do, if it's not already done for you, is get 0 on one side. So in the case of this example, that means moving the 1 to the left-hand side where it changes signs. So you get 0 on one side. Then you want to factor this polynomial and find out where it's actually equal to 0. So for a moment, you're going to treat this as though it was an equation. That is 6x squared minus or plus x minus 1 equals 0. And you want to solve that equation. Now typically for these problems, it's going to mean factoring. You could use the quadratic formula in this case, but this one factors. The factorization is already here. So I have this times this equals 0. One of these has to be 0. Either x is 1/3 or x is negative 1/2. Now if you stop here, then you're confusing this problem with a polynomial equation, okay, where all you have to do is find out where it equals 0. We want to find out where this polynomial is greater than 0. So what I suggest is this. We're going to put these two numbers on the number line, negative 1/2 and 1/3. And that divides up our number line into intervals. So let's think about the intervals that this gets chopped up into. So there's an interval from negative infinity to negative 1/2. And how about the middle interval? What's in the middle? Good, negative 1/2 to 1/3. And finally 1/3 to infinity. Now the important thing to understand about these problems is that your answer will be one or two of these intervals. You're not just going to get a couple numbers like 1/3 and negative 1/2. There's going to be more to your answer. Now what we need to do is we need to figure out where this polynomial is actually greater than 0. Now that's going to happen in these intervals, but where it happens, well, we don't know yet. So my suggestion is that we test points in the intervals. So what happens is that the polynomial can only change signs at these points. Change signs at negative 1/2 and 1/3. But is it positive in this interval or negative? Positive here or negative? Positive or negative? We don't know. So let's come up with some test points. What would be a number in this interval to the left of negative 1/2? Negative 1 would be a good one. How about in the middle interval? And then how about we do 2, just to do something a little bit different and interesting. So those are our test points, and we want to test those back in the original inequality that had 0 on one side. So coming all the way back up to here, we want to test those points in this expression. Now there's a couple ways you can do this. Since not everyone has a graphing calculator, let me first start by showing it by hand. So we'll start by testing, bless you, testing negative 1. So we're going to put negative 1 into that expression. 6 times negative 1 squared plus negative 1 minus 1. Well, what happens when I do 6 times negative 1 squared? Well, that's 6 times 1. Minus 1 gives me a 4. Now, I don't really care if I got 4 or 4 million. What's important to me is the sign of that term. And in this case, this is positive. So let me write a little positive up here. I want to keep track of what's positive and what's negative. Well, let's move over to the next interval. Yes, please. Yeah, go ahead. We needed to choose points in each of these intervals to test our polynomial. We want to try and decide where it's positive or negative. So these could be any points. I could have chosen negative 11, negative 30, etc. It just has to be in this interval. Now, for this one, 0 is a good choice. You could have chosen 1/10. You could have chosen 1/100th. But those are tougher to plug in. Because remember, whatever point you choose, you're going to have to plug it into this expression. So it's not a bad idea to try and give yourself as friendly of a point to deal with as possible. Bailey?
Say so if I were to put in negative 11 for the first point, would it still come out as positive?
It should. Yeah. In fact, what I'll do in a minute is we'll go back and check some of those other points. We'll check negative 11 and maybe a couple more just to show you that it doesn't really matter what point you choose. And this is where doing this on a graphing calculator is going to become a lot handier. Now, let's finish doing it by hand here for this first one. We'll test 0. So 0 is pretty easy. 0 is a nice test point. I always choose 0 when I can. What do I get when I plug in a 0 into my inequality? -1. Good. What's the important thing to get out of that when I put in the -1 or put in the 0? It's negative. All right, so let's put a negative up here. And I'm putting it up here because these are the intervals that are going to represent our solution. Finally, we'll test 2. So it's going to be 6 times 2 squared plus 2 minus 1. I mean, I think you can almost eyeball that one, right? It's not going to be negative. So it's actually going to be 25, I think. We can check it later, but it's certainly going to be greater than 0. So, thank you. So it's positive. Now, let's look back at our inequality. Are you comfortable with how we decided positive, negative, positive? That's simply by testing points. Let's look at the inequality. We want to know where it's greater than 0. So if we're trying to find out where it's greater than 0, does that mean we're trying to find the negative interval or the positive intervals? Which ones do I want for my solutions? The positive intervals, right. So these two right here. Those are your solutions. So your answer is negative infinity to negative 1/2 union 1/3 to infinity. So that's your final answer. It's both of those. So what's frustrating for me is when I grade exams and people just stop when they find negative 1/2 and 1/3. If you're doing that, you're treating this as if it was an equation. It's not. It's an inequality. On the exams, what I'll do is I'll write solve the inequality, and I'll put inequality in italics to try and remind you, oh, you got to do a little bit more on this one than just solve an equation. Yes, sir.
So the ones that were positive, highlight.
Yes, the positive intervals. Now, if this was a less than 0, then I would have chosen the negative interval. Okay, so that would have been the difference. But yeah, in this case, it was a positive one. Bailey?
2 questions. Union, is that and or?
Or.
Okay. And then, say it was only the negative one, would it only be negative 1/2 or negative 35?
Yes, it'd be.
1/2 and 1/3?
Yep, it'd be that interval. Now it's not just listing those 2 points. It's everything between there. So really, what it's saying is it's everything here, not including the endpoints, but in the interval. Just like I wrote it here, negative 1/2 to 1/3 in parentheses. Okay. How can you what?
Why we choose positive here on
Well, it's not a choose. It's just when we tested points from these intervals. Now keep in mind that these points are inside each of these intervals. So when I put in -1, the result was +4. When I put in a 0, I got a -1. And when I put in a 2, I got a +25. So positive, negative, positive, and that's what we wrote up here. Positive, negative, positive. All right. Now, Bailey asked a good question that I haven't got around to answering yet. What would happen if I chose -11? Well, my suggestion, and what I think is easiest to do, is to use a little technology in working on these problems. So if you take your calculator and plug in this equation, 6x squared plus x minus 1, so plug it into your y equals table, or y equals, let's see, the equation editor, then we can make our calculator do the work for us. Now, there is a little adjustment that we're going to make to our calculators on a one-time basis. So hit the second key, then the window key. This should take you to a menu called Table Setup. And down at the bottom, you'll see Independent. Make sure that's set to Ask. If it's not, cursor over there with the arrow keys and press Enter. So second key and then the window key, because above that you'll see Table Set. And set Independent to Ask. And leave it there for the rest of your life. Okay? No, don't change it. It's really convenient to have it that way. Now, if you're getting lost in something like this, then the instructions on how to do this are on the back of your handout. So you can take a look at that there if you need a reminder at some point. But let's do a table now. If you hit second and then table, what it's going to do for you is set up a t-table. And that t-table is going to help us decide positive and negative. Now for me, I already have some values here, so I'm going to hit the delete key and get rid of these just to start fresh. And let's first type in -1, 0, and 2. And see that we get the same things here that we did when we got it by hand. Although it's certainly much more efficient. Which one? Hit the second key, then the graph key. Now, Bailey asked, well, what if I typed in -11? I said it should be positive still, right? Let's find out. -11, bigger number, but still positive. And that's all you care about off this list is positive, negative, and that's it. So, yeah, with a graphing calculator, it becomes a little bit easier. And I kind of encourage that because it's a little bit more user-friendly. You know, it eliminates some arithmetic errors. The thing that you have to be perhaps most careful about is making sure that your numbers are actually in these intervals. Sometimes people say, oh, well, I'll choose 0 for this. Well, no, that's in the middle interval. So other than that, you should be in good shape. Okay. How are we looking on this first one? Yes.
So for exams, if we do use our graphing calculator, like,
That's fine.
are we gonna lose points for not writing out like tests?
You know, you could show me what points you're testing and you just show me the results of the test, but no, I don't need to see this stuff by hand. No, that's arithmetic, and this is not a course in arithmetic. I'm very comfortable with using the technology. I encourage it. And for those of you who don't have a graphing calculator, as usual, I'll be bringing those to class, and you can always borrow one. All right, Mitchell? No? Good? All right, you got a question? Okay, you look like you're ready to ask one, so. Okay. All right. Anything else on that last one? Let's try this one. Now, the nice thing about this one is that I've already got 0 on one side. So the next thing to do is to what? Yeah. We're going to set equal to 0 and solve. So typically that's going to involve factoring. And I'll let you in on a dirty secret. These problems are long enough and challenging enough that I'm not going to give you something that doesn't factor. I'm not going to make you use the quadratic formula in addition to everything else. So it will factor. Now, when we factor this, we get a couple solutions. What are they? X is -4 and X is 2. Good. So let's put those numbers on the number line. So -4 and 2. Now, Mackenzie, those two numbers break up the number line into 3 intervals. What are those intervals? Good. Good. So these are our intervals. Lisa, what would be some good test points? I need some points in each of these intervals. All right. So -6, 0, excellent choice, and 4. Sure. Cool. So whatever points in these intervals you want, but as we did with the last one, I suggest you kind of make it easy on yourself. Now I'm going to go back to some technology. I'm going to plug this function into my graphing calculator in the y equals key. The y equals key, then clear x squared plus 2x minus 8. And let's choose Lisa's points here. So that was -6, 0. Oops, wrong menu. Let's delete those. So hit the second key, then the graph key, go to the table. You can hit the delete key right here to get rid of all the old values so you don't confuse yourself. -6, 0, and 4. And we get positive, negative, positive. Perfect. So let's write that down in terms of our intervals. Positive, negative, positive. And now we need to decide which one of these intervals satisfies the inequality. So here's your inequality. Do I want the positive interval or do I want the negative interval? The negative interval. Yeah, I want this one. So I want -4 to 2. Do I have to include the endpoints? Should I have a bracket or parenthesis around this? Parentheses, good. If this was a less than or equal to, then you'd be using brackets around these. But with just a less than, that's the easy case for you guys. Everything gets parentheses. So your answer is simply -4 to 2. Now, I wouldn't be terribly happy with that on an exam because, it's hard to tell the difference between that and somebody who just stopped right here. It's, oh, my answers are -4 and 2. So I'm a little bit careful about asking questions like that, which is kind of a hint if you think through it carefully. All right, so that's problem number 16. Let's do a few more here, starting with problem number 50. Before I move on to 50, any other thoughts for problem 16? I like to do problem number 50 because people like to take all kinds of crazy shortcuts on it. And you got to be really, really careful. In fact, just don't do it with a problem like number 15 or number 50. Now, let me just ask you, what does it look tempting to do? Yeah, take the square root on both sides, right? Looks like, okay, square root on both sides, x squared and equal to 4. Done. Not. All right, so can't do that, but let's see how it should really work. What's the first thing I should do if I'm kind of following along with those steps on our sheet? Subtract 16. So I want to know where x squared minus 16 is greater than or equal to 0. Okay. So subtract 16, then what? Mila? Thanks. Factor. So x minus 4 times x plus 4. I want to know where that equals 0. Where does it equal 0? Good. X equal 4, x equal negative 4. So again, that gives me some test points, or it gives me some intervals, and from which I'll get some test points. So negative 4 and 4. Kyle, what intervals do I get?
Negative infinity, negative 4, negative 4, 4, 4, infinity.
Nice. Oops, parenthesis there. Krista, I need some test points. What would be some good test points here, please?
-5.
Good.
0. And then 6.
Sure. 5, 0, and 6. Now, we're going to test them in this expression right here, the one where we got 0 on one side. Now, for this one, let me go back and remind you that you don't always need a graphing calculator. You can do it by hand. All we really need to know is positive or negative, right? So, for those of you who don't have one of these things, these toys at home, so here's another look at doing it by hand. So I'm going to test negative 5. So negative 5 squared minus 16, 25 minus 16. You don't even need to rack your brains to come up with the number 9. All we need to know is the sign. It's going to be positive. If I test 0, 0 squared minus 16, negative, right? I mean, again, you don't have to think about this one. And the last one is we're going to test 6, 6 squared minus 16, 36 minus 16. Again, positive. You don't need the numbers. If you want to come up with the numbers, that's great. If you want to plug it into your graphing calculator, that's great too. But all we need is positive, negative, positive. So let's put that up here with our intervals. And I strongly encourage you to, write down these intervals as you're going through, because so many times people are just going to stop right here and give me 4 and negative 4 as the answer. You're going to get 1 or 2 points out of 7 if you do that. I mean, you're really missing out on the problem if you stop right here. Which interval or intervals should be our answers? Good? All right, those two intervals. Now, there's a little something that's different about this one as opposed to our previous two. What is it? What's different? Yeah, because of the greater than or equal to, these numbers can actually make this expression equal to 0, and that's fine. And that's going to happen at negative 4 and 4. So negative infinity to negative 4, bracket, union, 4 to infinity. Infinity and negative infinity always get a parenthesis. In this case, the 4 and negative 4 get a bracket. How are we looking on number 50? Now, one of the things I want you to get comfortable with is plugging these expressions into a calculator and testing points. And it's not so much for the sake of these polynomial problems as it is for the rational polynomials that are coming up after we do this one. So, any last thoughts on number 50 for us? Please. It's not just the numbers, it's the whole interval. So what looks confusing about this, it looks like a coordinate pair. It's really that right there. It's that middle interval between negative 4 and 2. So it's all those numbers there. So if you'd like, let me give this a geometric interpretation. So you can kind of see where this positive, negative, positive stuff is coming from. So back with problem, the first problem we did, the one on our handout, if you were to graph y equals 6x squared plus x minus 1, it's going to cross the graph exactly where, cross the x-axis exactly where we thought it would, which is at negative 1/2 and 1/3. And then we tested points. Well, I think you can see visually, and I've kind of highlighted over here, that to the left of negative 0.5, the function is positive. It's above the x-axis. And same thing with to the right of 1/3. It's between these two that the function dips below the x-axis. So the function can only change signs at these points. And with a parabola, you're going to have positive, negative, positive, or sometimes your parabola is going to be facing upside down, in which case you would have had a negative, positive, negative. So you tend to get things that alternate in sign. The problem with the graphical approach is that it's much more difficult with rational polynomials. Just get the mechanics down right now. Okay, I think I'd like you to try one. So let's try problem number 20. So x squared minus x is greater than or equal to 72. And I'll do a little timeout here as I walk around and try and help out. Okay, so let's take a look at this one together. First thing you're going to do is get 0 on one side. So that means moving the 72 to the left-hand side. We're going to factor and solve x squared minus x minus 72 equals 0, which is x minus 9 times x plus 9, or plus 8. I get two solutions of 9 and negative 8. Let's put those on a number line. So negative 8 and 9. That gives me intervals from negative infinity to negative 8, negative 8 to 9, and 9 to infinity. Kennedy, what did you use for test points? All right, so negative 10, 0, and 10. Let me use those as well. So there's our equation. Let's go to the table. Oops. So negative 10, 0, and 10. And the big important thing to see is we got a familiar pattern. Positive, negative, positive. So let's write that down. Plus, negative, plus. Which intervals do we want? The positive or the negative ones? Positive intervals. We want to know where it's greater than or equal to 0. That's here and here. Those two. So, yeah. The only thing that we need to remember is that we want brackets because we're going to include the endpoints. So it's going to be negative infinity to negative 8, bracket, union, 9 to infinity. And again, brackets. So there's our answer. Now it's tempting to think that, well, gee, these are all going to work out, negative, positive, negative. It's not exactly true. Let's take a look at problem number 60. X squared plus 4x plus 4 is greater than 0. Maybe you just want to sit back and watch this one. I want to kind of do this one a little bit fast so we can get on to the rational polynomial part of this. We got 0 on one side. This factors as x plus 2 times x plus 2. Better yet, x plus 2 squared. So where does that actually equal 0? I'll give you a hint. There's only one place. Yeah. When x equals negative 2. So that gives me two intervals. It gives me negative infinity to negative 2 and negative 2 to infinity. Okay. So let's test some points. Norman. What will be some good test points here? Let's start in this interval. Sure. Negative 3 and 3. Sure. So negative 3 and 3. Now, I'll save you a little bit of effort here. When I test them, both of them are going to test out positive. Wow. So which interval or intervals do I want? I want both of them. So the question is, though, can I write negative infinity to infinity? Can I write everything? Yeah, it has to be greater than 0. So it wouldn't include what point? Yeah, it's like everything but negative 2. So your answer is negative infinity to negative 3, or excuse me, negative 2, union negative 2 to infinity. And if you just wanted to write x not equal to negative 2, probably be okay with that. I think I'd prefer to see the interval notation. But why are we getting such a strange result? I mean, it didn't even alternate in sign? And the answer comes when you look at the graph. So let's ditch this one. Take a look at y equals, let's just do x plus 2 squared, like that. And what's going on is the graph really never changes sign. It touches the x-axis, but it's always positive to the left and positive to the right. The only time it's not greater than 0 is when it's actually on the x-axis at its vertex. So that's why you're getting kind of a strange result. So I show that one to you mostly to let you know that there are other things that can happen other than just the very typical positive, negative, positive case. But that's generally what's going to happen is you're going to have things that are going to alternate in sign. Yes, sir. Great question. Yeah. If this was x squared plus 4x plus 4 is greater than or equal to 0, then yes, your answer would be negative infinity to infinity. So the answer to this would be, yeah, all real numbers. Does anyone remember the symbol that we wrote for that? Yeah, script R. All real numbers. So, I mean, that's bonus points. You don't have to remember that. If you do, that's great. Okay, let's move on to rational inequalities. So let me throw out some handouts here. 3, 4, 5. Help out. Kyle, can you help out? 3. And pass on to Abdul. A Coke or something?
That would be great. Maybe a cupcake?
Cupcake? Alright.
My chiropractor appreciates the fact that I'm getting food up.
Okay. Well, yeah, I wouldn't want to get on his bad side. Did you not get one? Oh, I'm sorry. Kyle, didn't I? Oh, okay. Alright, so let's move on and work with rational inequalities. Now, it's really kind of the same workflow. There's a little bit extra that you could get stuck doing, but in practice, I'm pretty kind on these types of problems because I understand that they are a little bit longer. This is a rational inequality. Why is it a rational inequality? It's because you have a rational polynomial on one side. So just like our work with polynomial inequalities, you got to get 0 on one side. But then there's a little extra step that, I'll say off mic that I've never actually made people do on an exam. All right. But you have to write this as one expression with one fraction. So what that would mean is getting common denominators. So you write 3 as being 3 over 1, multiply, get a common denominator, collect like terms in the numerator. What expression am I going to get over here when I collect the like terms in the numerator? Thank you, negative 5x plus 7. So it's this expression that we're going to start our work with right here. We want to know when this is greater than or equal to 0. And here I think the graphing calculators do give you an extra little bit of advantage. So, kind of like what we did with polynomial inequalities, we're going to start by figuring out where this numerator equals 0. So, the roots of the numerator, negative 5x plus 7 equals 0. I'll move the 5x to the right-hand side. Now, why am I moving the 5x to the right-hand side as opposed to moving the 7 to the right-hand side? Yeah, it becomes a positive 5. It's just a little bit friendlier. I get rid of the negative that way. Divide both sides by 5. I get 7/5 for x. Okay, great. So let's keep that point in mind. We got to do the same thing with the denominator. We got to find out where the denominator equals 0. So that's where 2x minus 1 equals 0. What could x equal? 1/2. Thank you. So let's put those two numbers on the number line. So you see where this came from. The roots of the numerator and the roots of the denominator. So that'd be 1/2 and 7/5. The rest of this should take on kind of a familiar flow. We're going to try and figure out where this is positive and where this is negative. But before I do that, let's figure out the intervals that this makes. It'd be negative infinity to 1/2, 1/2 to 7/5, and 7/5 to infinity. So one or more of those intervals are going to be our solutions. As before, we want some test points. What would be some good test points here? Go ahead. Somebody listed my favorite one. 0. Thank you. 0. Not too many real easy choices for this middle interval, but there is a good one. 1/4 would actually be in this interval, right? Because 1/4 is less than 1/2. And 7/5. Now you don't have to have a decimal value for that if you don't want. Just pick a number that's clearly bigger than 7/5. 2. Perfect. So 0, 1, and 2. The one thing that you have to be careful of when you're entering this into your calculator is that you do one of two things. You either write the numerator and denominator with parentheses, or if your calculator is sophisticated enough that you use parentheses in the numerator and denominator. So let's put that expression into our calculator. So I'll do this first one with parentheses. So left parenthesis, negative 5x plus 7. Now when you type in the negative 5, use the opposite key on the bottom of your calculator. Don't use the subtraction key. Negative 5x plus 7 divided by 2x minus 1. From there, let's go to our table. I'll delete that old value there, and I'll type in my test points. 0, 1, and 2. Gil, what's the information that I need out of this? Good. So negative, positive, negative. All right, great. Let's write that down on our sheet. So negative, positive, negative. Emily, which intervals do we want? Good. We want to know where this expression is greater than or equal to 0. And in fact, we want to know where it's positive. So we want this interval right here, 1/2 to 7/5. But we got to be a little bit careful about that. Let's write 1/2 and 7/5 down here. Notice we got a greater than or equal to here. So we got to think about the endpoints. I didn't say necessarily include them, I said think about them. The advantage that your graphing calculator gives you here is that it can give you a nice reminder. We can test these things. Let's type in the endpoints. Let's type in 7 divided by 5. Now when I hit the enter key, that 7 divided by 5 is going to turn into 1.4. It's okay. It's still 7/5. And I got a 0. Ask yourself this question. Is 0 greater than or equal to 0? So I put in a 7/5 and I got 0. Is 0 greater than or equal to 0? Should I Should I use that point as part of my answer? Yeah. 0 is greater than or equal to. It satisfies the equal to part, right? So I want to include 7/5. Let's take a look at 1/2. Type in 1/2. 1 divided by 2. Or you can type in 0.5. Doesn't matter. What do you get? Error. How are you getting an error? You didn't do anything wrong. Oh, wait. I got an error too. Why am I getting an error? Because what? Well, you can give me, let's be precise. Why am I getting an error? What is that 1/2 doing to this expression that I'm getting an error? I mean, it worked for everything else. What's going wrong at 1/2 that I got an error? Yeah, 1/2 makes the denominator 0, right? So effectively, you're trying to divide by 0, and your calculator knows you can't do that. Literally, it happened to an aircraft carrier one time that in its software that controlled the nuclear reactors, there was some branch of the program that resulted in a division by 0, and it shut the whole thing down. They had to tow this aircraft carrier back into port because they divided by 0. So, whoops, yeah, big whoops.
That's a big, expensive beast.
That's really big. I think it took 2 or 3 days to tow it back into port. Any case, we can't use 1/2, right? So what's that mean for my answer? Parenthesis. So you got to be careful with these rational inequalities with the endpoints, because sometimes you want them, sometimes you don't. But I mean, look, if you're unsure, there's a good way to test it. You just plug it in. Your calculator tells you, no, you can't use 1/2. That's nice and clear there. Okay, how are we with this first one?
My calculator did something really weird.
Let me see it.
Like when I enter in the y equals and I hit graph or table, then that comes up.
It's second table.
Oh, I was hitting this one. Sorry. Okay.
Okay,
Got it. Thank you.
you're welcome. Okay, so type in the numbers now and they should work. Let's try some more from the book. Let's try problem number 28. So x squared plus x minus 6 divided by x minus 4. And let's see. I want to know whether that's positive or negative. I didn't write that part down. Greater than or equal to 0? Perfect. Greater than or equal to 0. So there's a couple points that we got to find first. I need to know, for instance, where x squared plus x minus 6 equals 0. So let me start back around the room here. Lisa, how does that factor, please? Good. X plus 3. Thank you. X minus 2. So we get two solutions from there, right? We get negative 3 and 2. Thanks, Lisa. Second thing, I need to know where the denominator equals 0. Wait, I'll pull out my graphing calculator. I'll solve this in a second. All right. So the denominator equals 0 when x equals 4. All right. Now, if you're keeping track of things, we have 3 points. How many intervals do you think 3 points is going to give us? Well, 2 points gave us 3 intervals. 3 points gives us 4 intervals. So here again, it's advantage to the graphing calculator. So here's our four intervals. Negative infinity to -3, -3 to 2, 2 to 4, and 4 to infinity. I like and strongly recommend you write these down because a lot of times when people put their test points in, they get their test points confused with these points that give us our intervals. So if you've got your intervals written down, then you're not going to make a mistake at the end of the problem with grabbing the wrong interval. So, some test points. Lauren?
-5.
All right, good. -5. Favorite one, favorite one, favorite one. 0. Good. 0.
3
Mm-hmm.
and 8.
Perfect. So those are some good test points. I'm going to walk around and try and help you guys out. Make sure that you're able to do this on your calculators. You need parentheses around the entire numerator and entire denominator when you do this one. So I'm walking around making sure you entered your expressions correctly, because without that, then you're in bad shape.
Yeah, I know.
Okay, people seem to be doing pretty good on this. When I put those numbers into my calculator, I get negative, positive, negative, positive. That's the alternating pattern that I get. So it starts here, negative, positive, negative, positive. Which intervals do I want? Do I want the negative intervals or do I want the positive intervals? Positive intervals. I want to know where this is greater than or equal to 0. That comes from this inequality right here. So I want the positive intervals, that'd be this one and this one. Now, it's worth a moment, because I've got a greater than or equal to, I've got to think about the endpoints. Do I want to include negative 3, 2, or 4? And if you're not sure, look, you can just type those into your calculator. See what it tells you. So negative 2, actually negative 3, pardon me. So let's go back here. Negative 3, 2, and 4. So I can use two of these. I can use the negative 3 and use the 2, but how come I can't use the 4? Yeah, makes the denominator 0, so you can't use that one. Overall, your answer on this one would look like this. It'd be negative 3 to 2 in brackets union 4 to infinity in parentheses. So that's your final answer. Whew. How are we looking on number 28? Okay. Let's try problem number 30 as one last example here. So 6x squared plus 11x plus 3 over 3x minus 1. And I want to know where that's less than 0. Let's kind of make this problem 30-ish by doing less than or equal to 0. As it's written, the answers would end up all with parentheses. And you wouldn't have to think about brackets versus parentheses at all. I'll tell you here that more than likely, 99% chance I'll have a less than or equal to or greater than or equal to, because I want you to think about the brackets versus parentheses. Let's start with the roots of the numerator. 6x squared plus 11x plus 3 equals 0. Now, somehow or another we have to figure out how this thing factors, or figure out where it's equal to 0. In this case, if you wanted to just bail and use quadratic formula, that's fine, that works. I promised you I'd give you problems that will factor. Do you want to go through factoring this? You remember that trick to factor polynomials like this? 6 times 2 is 18. Two numbers that multiply to 18 and add to 11. 9 and 2. Yeah, 9 and 2. So I'll write that as 6x squared plus 2x plus 9x plus 3 equals 0. The first pair share a common factor of 2x. The second pair share a common factor of 3. So if I factor out the 2x here, that leaves behind 3x plus 1. What can I factor out of the second pair? 3. Which also leaves behind 3x plus 1. So 3x plus 1 times 2x plus 3 equals 0. If you set each one of these things to 0, and I'm sorry I'm not going to take the time to do that, but you'll get x equals negative 1/3 or x equals negative 3/2. So those are your two numbers that you get from the first part. Second part, I need to know where 3x minus 1 equals 0. So similar work down here, x equals 1/3. So we've got our points. We've got 4 of them. They're not necessarily the friendliest of points. That's okay. put those points on a number line. Make sure that you put them in order. What should be the farthest left point here? Good. Negative 3/2, negative 1/3, and then 1/3. So that gives us our intervals. So it would be negative infinity to negative 3/2, negative 3/2 to negative 1/3, negative 1/3 to 1/3, and 1/3 to infinity. Let me remind you, for those of you who have an up-to-date graphing calculator, there's perhaps a safer way for you to enter in these expressions. So let me do that for this particular one. So when I go to my y equals key here, I'll clear out the previous expression. And this time, I'm going to hit the alpha key, then the y equals key. And what that does is it pulls up a little menu that allows me to type in a fraction. If you press the number 1 or simply press enter, you can type in a fraction. Now this has a numerator and denominator, and you don't have to worry about the parentheses, much like we did with problem 28. So 6x squared plus 11x plus 3 divided by 3x minus 1. Now if you don't have that feature, if you got a TI-84, your calculator can be updated to have that feature. Or the other possibility is just type it in as normal. 6x squared in parentheses plus 11x plus 3 divided by, again, parentheses 3x minus 1. So it might change the look of our output, but it's not going to change our outcomes. So when we go to our tables, then we see that in the one case we get fractions, in the other case we get decimals. But in either case you can tell what's positive and what's negative. Let me delete these values so I can start over. I need some test points here. What would some test points be? All right, minus 2. How about here? Yeah, minus 1. Always go for the favorite, and you can do 1 or 2. I just chose 2 for variety. So, negative 2, negative 1, 0, and 2. In either case, we can get the same information out of this. What information do I need off this table? Yeah, what's negative and what's positive. So it has an alternating sign pattern, negative, positive, negative, positive. Let's write that down. So negative, positive, negative, positive. Which intervals do I want, Kyle? Do I want the negative intervals or do I want the positive intervals? Yeah, I want the negative intervals. So I want this one and this one. Good. So those are going to be part of my answer. Am I going to include the endpoints or no? Or maybe I should say it like this. Which endpoints can I include with a bracket? Good. The only point that I can't include with the bracket is this one right here at 1/3, because 1/3 makes the denominator 0. So other than that, these get brackets. So negative 1/3 gets a bracket, but 1/3 gets a parenthesis. And there's your final answer on that one.
Can you say that 1/3 gets a parenthesis again?
because 1/3 makes the denominator 0. So if you put in 1/3, 3 times 1/3 is 1, minus 1 is 0. You end up dividing by 0. Now, another way, if you're just not sure, then you can type in those points. You can type in -3 divided by 2. Oops, go 2. Go 2. Oh, -3 divided by 2. And -1 divided by 3. And 1 divided by 3. So of those 3 points, I can't use the last one because that creates a 0 in the denominator. All right, but these other 2 are fine because 0 is greater than or equal to 0. I can use those 2 endpoints. How are we looking on number 30? Did you do the point that you can work on these at home?
I didn't get those answers on my copy. I'm trying to figure out what I did wrong.
Are you guys getting the same ones that I did? Okay. Maybe you entered the expression wrong. Double check that you got something like one of these two. You can't do it on yours. Sorry. 83 is too old. 84 can be updated. Okay. Yes. I'm sure it can. 84s can be updated. The operating system you want to get to is 2.55 MP is the operating system. You're going to need to download some software from Texas Instruments. You would go to education.ti.com and you need to download TI Connect. I think that's the software that you're going to need. And if you run into problems, 800 TI cares. Isn't that special? They care. All right. Let me give you some homework done. So for homework, try 15 through 29, 35 through 45, and let me just double check something here. 49 through 59. Okay, and that's section 10.5.